This is a great question in terms of Bloom's taxonomy. No past exam question like this. We are given an individual's total wealth is in her home, valued at $300,000. In a given year, there's a 2% chance of total loss due to a fire. The individual is willing to pay $20,000 for insurance premium a year to insure her home. We are also given a standard utility function. We need to compute the risk aversion A for this individual. We have two scenarios for losses. The first scenario is when a person has no insurance, and the second scenario is with insurance. Since the individual is willing to pay $20,000 for insurance in scenario number 2, the utility of scenario number 2 must equal the scenario number 1 utility without insurance. Let's compute the utility in scenario number 1. There is a 2% probability of a total loss, so the return is negative 100%, and 98% probability without any loss, so the return is 0%. Now we can use Excel sum product function to calculate the expected return. Next, we calculate the variance using the variance formula. We can type out the formula to get partial credit just in case we make a mistake in the calculation. The first item is 2% times negative 100% minus expected return negative 2%. Make sure we use absolute reference for expected value before dragging down the formula. The variance is summed up to be 0.0193. The utility is expected return 2% minus 0.5 times variance 0.0196 times A. Now we can move on to the second scenario with this insurance. It's certain if there's a fire, the person would not lose her wealth because the insurance would pay out, so there's no gain or loss. But the person must pay $20,000 for insurance premium. That's 100% probability. That's money out of her pocket, so the return is negative 20,000 divided by 300,000 equal to negative 6.67%. The expected return is also negative 6.67%, and the variance is 0. Plugging the numbers into the utility function, the second term is 0, so we are left with expected return being the utility, which is negative 6.67%. Finally, we can set the utility equation from scenario number 1 equal to negative 6.67% that we just calculated. I put the individual number in its own cell so that I could use it in the cell formula later. Also, I reference each item to its own source cell to do less typing. A is equal to negative 6.67% plus 2% and then divided by negative 0.0098 equal to 4.7619.